This is 2018 Calculus BC, and we're doing number 2. So I'm a little perturbed. I just did this problem, recorded it, and it didn't save it. And so what I'm going to do is just explain the work I already have done. That's my plan of attack. So what do we have? We have people in a boat. Wow, and that noise you're hearing is my hot pot heating up water for my tea. Sorry about that. I'll try to talk fast and loud so you can't hear it. But researchers on the boat investigating plankton at sea at the depth of H meters. So H is the depth of the water. And what we know is this, that every cubic meter, so if you took a box, which is 1 meter by 1 meter by 1 meter, and put the water in it from the ocean, you would have millions of cells of plankton. How many? Here's the model. So if you picked H and picked the depth H here and here, that will tell you how many millions of plankton cells are in that cubic meter of water. So that is a density. So if you want to find out how many plankton cells there are, you find out how many cubic meters of water there are and multiply by this. So that concept you need to understand. So the density times the volume gives you the number of plankton. Now the first part's pretty easy. So I plugged in this P of H as Y1 in my calculator. So just punch that in. And then you go to home screen, you do math 8, and then you do alpha Y1, actually not alpha Y1, you put in your X for DX, you hit alpha, trace, you select Y1, and at the point 25, and you should get the answer negative 1.179. But we're not done. What are the units? So P prime in differential form is dpdH. P, the units we're given here, is millions of cells per cubic meter. So millions of cells per cubic meter. dH, H is the depth in meters, so it's millions of cells per cubic meter per meter. And they want to interpret the meaning of this. You should all know if a derivative is negative, then the function's decreasing. So we know P, which is the density of plankton, it's decreasing. So I wrote the density of plankton, which is P, is decreasing at the rate. P prime is a derivative or a rate. So at the rate of 1.179 millions of cells per cubic meter per meter. You can write this as meter to the fourth on the bottom, or in words, millions of cells per, write the word per, m cubed per m. So all that's fine. So part B, consider the vertical column of water in the sea. So I drew a column here. It doesn't have to be cylindrical. I just chose it to be. You could have made it a square or a triangle. It's just a column of water. I chose a cylinder because, I don't know, it just seemed better and easier to do. But we want to figure out how many plankton would be in this column of water from 0 to 30 meters. Now they tell us that each cross section has an area of 3. So if you were to slice it and take the area of that circle, it would be 3. If you sliced it here, took the area of the circle, it would be 3. So how do you figure out how many plankton there would be? And the problem is you can't just take the volume of the whole thing and multiply it by the density, because at each layer, the number of plankton changes. So we have to look at the number of plankton in this slice, the number of plankton in the next slice. So we take all the slices and add them up. But how do you add up a bunch of stuff? That's called integration. So we want to add up from 0 to 30 all the little slices of water and how many plankton there are. So the number of plankton is the volume of that water times the density. But how do you find the volume of this little disk? Well, it's the area of the shape times the thickness. Well, the area of the shape is 3, and the thickness is dH. So what we have, I will zoom in so you can see this. The thickness from there to there, that's DH. So that's why we have DH here. And so these two combined get us volume, and this here is density. And so that gives you the number of plankton in each little slice. So in your calculator, you hit math 9, 0 to 30, and then hit 3 y1 dx, and you should get this many plankton. And so your answer for B is 1,675 million plankton cells, because they asked, if you read it carefully, they asked for the nearest million. So you don't want those decimals there. So that's part B. We're done with that. Okay, part C. Oh, I have it here. Okay, good. Part C is crazy. It takes a while to process, and it's kind of confusing. So what happens if you are greater than 30 meters deep, they give you a new function. Here, let me erase this. Whoa, that was weird. Erase that. It came back magically. So F of H is the density if you're greater than 30 meters. So you have a new function for deeper. So you want a function. Okay, you want an expression. Whoa, that's not the right tool. You want an expression involving one or more integrals that gives the number of plankton cells in millions in the entire column. Okay, so the entire column is going to go to infinity. The entire column, it goes to the bottom of the ocean. Now, technically, you can't go to infinity because the ocean only has a certain amount of depth, but they are wanting to find like the border case if it did go to infinity. So what I did here, we need to ignore this stuff up here. I'll come back to this. This is like pre-work. But how do you do it? We do it the same way as we did before. It's going to be the volume of each level times the thickness. Well, the 3 times dH, that's the volume of that slice of water, and the pH, that's the density. But it changes a little bit. That's still the volume of water. So when you are deeper than 30, from 30 to infinity, the density changes to F of H. So that's our new density. Okay? So we found this answer right here. We found in the previous problem, so it's right there. But here's the problem. We don't know F of H. So how do we find this integral? Now, here is where it's crazy. So you're told there's this other function, U of H. Okay, another function. And they're just saying U of H is bigger than F of H. We don't know what F of H is, but all we know that it's always less than U of H. And then they tell us this interesting deal here. The integral from 3 to infinity of U of H is 105. Okay, they just throw that out. So what I did, I just came up with this basic statement, which should make sense. Well, since U of H is bigger than F of H, this integral is less than this integral, and this equals 105 because they told us that here. So that's what I started with. And then here, I don't know what this F of H is, but I want to know 3F of H. So what I did, I plugged a 3 in, multiplied each part of this by 3. And this is 315. So that's the side work. So I'm going to say that is less than 315. So what I do a less than sign and put a 315 because I know this is less than 315. When you add these up, you get 1,190.414. And it wants you to prove that the number of plankton has to be less than 200 million. Well, this is the number of plankton, and it's less than 1990.414, or 2,000 million. That's less than 2,000 million. So you can conclude that the number of plankton has to be less than 200 or 2,000 million, which I believe is a trillion. So that's part C. And then part D. So for those of you taking the test in this COVID year, you don't have to know parametric equations, but I'm still going to do this because we'll probably do this next year. So part D, you have a boat moving and its position is determined by this vector parametrically, and they give you x prime and y prime, and they want to know the total distance the boat traveled. This is an arc length of a parametric, and you have a formula you all should know. It's right here. This is the formula for an arc length, or the distance traveled by a parametric. Well, x prime is given, I put that in my calculator. Y prime is given, I put that in my calculator. And you just pop this in your calculator, you get the answer, you're done. Now, the answer, the scoring guideline, actually summarizes it and says the total distance traveled by the boat over the time period from 0 to 1 is, and they give the answer in meters. Now, traditionally, in previous ones, they didn't have you write that out, so I would assume you wouldn't need that. But I'm going to leave the answer like this. I'm going to kind of do some research and let you know if it's otherwise. That's it.